Okay, good day, future engineers. Let's tackle now on the design for Flexure and Shear. So last time, atong gibulag no, si Flexure o si Shear. So natin lang nga problems regarding design for Flexure and then design for Shear. So during nga topic, actually there is really nothing new, nalay modification gamay, but actually quite related sa itong previous examples on the bending or the flexural stress and also for the horizontal shearing stress. Okay, so let's start now with a review. So, di ba if you remember, ato ang maximum bending stress is equal to MC over I. So, moro gini siya. Always remember this formula. And then our maximum shearing stress or ato ang shearing stress general formula is equal to VQ over IB. So, M na to is the maximum moment. So, M na to is the maximum moment. And then I na to is the moment of inertia. Ato ang V is the maximum shear. Q na to is the moment of area. And then ang ato ang B is just the width or the breadth of the beams. So let's say naatay ko ano natay usa ka beam diri no rectangular section because rectangular section is the common man nato nga ginagamit for the beam design or the beam section. Let's say this is the base B and then yung height is D. So ang ato ang neutral axis diri is nasa tunga, di ba? This is the neutral axis. Therefore, kani siya is just katunga sa D or D over 2. So from this one, we have C is equal to D over 2 for our maximum bending stress. And then ang ato ang I is just equal to 1 over 12 BD cube. So substituting this value for our FB, we have M times D over 2 over 1 over 12 BD cube. So we numerator times the reciprocal of the denominator. We have the numerator M times D over 2 times the reciprocal of the denominator. So we have 12 over 1 times 1 over BD cube. Para mas dali lang ni siya, no? We have 12 divided by 2. Here we have 6. And then si D, makancel si D. Diri sa ubos. And then may mo na siyang square diri. So may tabo, we have FB is equal to 6M over BD squared. So for ato ang kuan, so mo na ni siya. We have this formula for the bending stress. And then you also have this one, 6M over BD squared. Next one, for our shearing stress, okay, ang ato ang kuan for our shearing stress, ato ang maximum nga Q is just equal to kani man ang area, di ba? The maximum Q na to nga area is base times height, so that is D over 2, times Y bar is just this distance. And then we know that this distance is just equal to 1/2 of the D over 2, which is equal to D over 4. So times D over 4, we will have BD squared over 8 sa Q. And then what else? I think there is already nothing new. Then we solve for our shearing stress is equal to equals to V times ato ang Q, which is equal to BD squared over 8 over IB. So atong I again, that is 1 over 12 BD cubed times B. So, pwede kaya po na ito i-apply. We have the numerator nga V times BD squared over 8 times the reciprocal of the denominator, 12 over 1 times 1 over BD cubed times 1 over B. So, 12 over 8, that is, makancel na siya. We have 4 and 3, and then we have 4 and 2. So, itong shearing stress is equal to 3 over 2 times what? V, and then we have BD here. So, makancel si B, makancel po si D. Weird. So, D na lang mabilin sa ubos. So, we have 3V over B times D. So, itong shearing stress is just equal to 3V over 2BD for the rectangle. So, remember this formula for maximum bending stress, flexural stress, kaya ito man yung magamit diri. We have MC over I, and then for our shearing stress, general formula, that is VQ over IB. And then, considering a rectangular beam, so ato ang maximum bending stress, diretso na 6M over BD squared. And then horizontal shear stress na to for rectangular beam, diretso na 3V over 2BD. So, so this is only applicable for rectangular section.